Iron is the foundation of our modern world. We use it to build skyscrapers, bridges, and ships. Yet, this seemingly indestructible metal has an invisible, deadly enemy. Nature destroys it from the inside out. And the tool for this is rust. To understand why metal breaks down, we have to look at the atomic level. And a real chemical drama awaits there. This here is an iron atom. And chemically speaking, iron is rather unhappy. It is unstable. Its outer shell holds electrons that it doesn't actually want. Iron would love to shed this burden to achieve a stable state. And that's where the perfect counterpart comes in: oxygen. Oxygen is greedy. It is desperate to find the very electrons that iron wants to give away. When the two meet, it happens. A chemical reaction we call oxidation. The iron loses its electrons to the oxygen. The hard, shiny metal transforms into a completely new substance, iron oxide, better known as rust. The fascinating thing is that in completely dry air, this hardly happens at all. The atoms are too sluggish. They need an intermediary to bring them together. And that intermediary is liquid, commonplace, and extremely dangerous.
We now know that iron wants to give up its electrons, but in dry air, absolutely nothing happens for days on end. The atoms are trapped. They need a medium in which they can move. They need a liquid catalyst, water. As soon as a tiny droplet of water settles on the metal, the surface transforms into a microscopic battlefield. The water acts as a bridge. It enables the charged particles, the ions, to migrate in the first place. Electrochemistry comes to life. But there is one factor that turns this process into an absolute nightmare: salt. When road salt in winter or sea spray comes into play, the metal disintegrates in record time. Salt dissociates into sodium and chloride ions in water. They make the water extremely conductive. It is like building a highway for electrons. The rust turbo has been ignited. Rust eats away at iron mercilessly. But why doesn't this destruction actually affect all the metals on Earth? Why do aluminum bridges or copper roofs stand in the rain for decades without simply crumbling into dust? But instead of a porous layer, an ultra-thin, diamond-hard barrier forms in a flash, the aluminum oxide layer. This passivation layer is completely airtight and watertight. It stops oxygen before it can destroy the underlying metal. With iron, it is a disaster. Its oxide layer contracts, cracks, and flakes off, exposing fresh metal, an unstoppable vicious circle. Since rust threatens our entire civilization, science has developed clever defense methods to protect iron. The simplest method is a physical barrier. Varnishes, special oils, or greases simply and effectively block out water and oxygen. But there is an even more ingenious method. During the galvanizing process, the iron is dipped into molten zinc and acquires a protective metallic suit. On the high seas, gigantic ships use so-called sacrificial anodes. These are thick blocks made of a less noble metal, such as magnesium. The electrochemical current flows in such a way that only the anode rusts away in the salt water, while the ship's hull remains forever pristine.
Rust never sleeps. But which tool or car in your life lost the toughest battle against rust? Be sure to let me know in the comments below. If you don't want to miss out on future deep dives into the invisible world of science, hit subscribe and join our community of explorers. Thanks for watching and see you in the next video.